In this video, we're going to be talking about how to use polynomial equations and functions to represent the cost, revenue, and profit for a company. In this example, Earl owns a biking company and he manufactures and sells them. Each bike costs $40 to make, and their fixed costs for the company are $5,000. The $5,000 could represent the rent of the building he's working in, how much he has to pay his employees, or other additional costs he might find on a monthly basis, for instance. He sets his price by using the equation lowercase p of x equals 300 minus 2x you see in front of you. The x in all the equations we're going to see in this work are representing the number of bikes that are being sold. So depending on how many bikes he's selling, that determines how much he has to charge for them. So by that price equation, if he's selling lots of bikes, he doesn't have to charge as much. If he's only selling a couple bikes, he's got to charge more, which should make logical sense to you. Now we're going to be looking at finding the revenue function first. So keep in mind that revenue is basically all of the money you are bringing in your business before accounting for anything else. So really, it is basically, well, how much does the bike cost times how many bikes you're selling? And that is what we see in number one here. X is the number of bikes they're selling. And then P of X, the equation we already have seen up here at the top here, 300 minus 2X would be the price. So X, number of bikes, times the price would give us 300X minus 2X squared. So that would be a quadratic polynomial or a quadratic binomial to be specific. And we're going to look at that one later in Desmos, but we have our revenue equation. It tells us how much money is coming in depending on the number of bikes sold. So for instance, if he only sells 2 bikes, we would do 300 times 2 minus 2 times 2 squared. And that means he's bringing in $592. Which you would hope he'd be bringing in more than $592, given that his fixed cost is $5,000. So he's got to hope he's selling more than 2 bikes, is what I'm saying. So now moving on to cost. So a business cost includes the fixed cost of $5,000. We talked about that a little bit. And then variable cost is another economics term where basically it's, well, how much you are bringing in based on how many products you're selling. So he makes $40. The cost of each bike is $40, so he's got to add that to per bike to the $5,000 he is selling. So you can see $40 times the number of bikes X plus $5,000 gives us a cost equation of 5,000 plus 40X. You can tell that that is a linear function because cost just by itself is going to keep increasing up and up and up depending on how many bikes he's making. And that would have no upper limit whatsoever. He would just keep having to pay more and more if he's going to keep making bikes. Now, if we've talked about revenue and cost, and you know anything about economics, you might be able to guess that profit is what is coming next. Profit is when you take your revenue and take away all of your costs. That difference is representing your profit. And that's what we can see in right here. Profit, capital P of X, is revenue R of X minus C of X cost, and that gives us our profit equation. So we take our original revenue equation from number 1, 300X minus 2X squared, and we are subtracting our cost equation, 5,000 plus 40X right here. And we get, if we subtract that whole second parentheses, each one of those parts becomes negative, and then we have an equation in standard form as a quadratic that would be our profit equation. So now we've gone through the 3 parts. Moving on to number 4, a company's break-even point is important. Break-even point is when your revenue function and cost function are going to have the exact same value. This implies that basically your profit is 0. You haven't made or lost any money. Typically, businesses start out below your break-even point where they're losing money at first, eventually working towards this point, and hopefully, as they keep going, they'll look to get above their break-even point and start making a profit. for small businesses, restaurants, things of that nature, that is very challenging, and that is the reason why a lot of small businesses, like restaurants, for instance, or a bike store like this one that Earl owns, tend to fail at first because they never really make it to the break-even point or even that profit stage. So now we're going to be looking for those break-even points, and we also want to see if we can maximize our profit. So let's go to Desmos now to do that part. Now we have our price equation here, and we have our cost equation and revenue, and our profit equation is subtracting these two. And we can put in our profit equation that we just found out in our last slide. If we look back at it, we found out it was negative 2x squared plus 260x minus 5,000. Okay, so I think that was the correct one. Yep, looks good. So now we want to think about first, to label our X and Y axis. So if we click on our wrench icon, our X label is number of bikes sold, or number of bikes in general, I guess you could say. And then our Y is going to be dollars. All of these revenue, costs, profit are all measured in dollars. So that is in common between all of them, even though they're not all exactly the same thing. So obviously our minimum for our number of bikes has to be 0, but our maximum isn't quite as easy. If we look at the price of our price equation at the top here, we have 300 minus 2x. So if we think about how we'd figure that out, if we set up an equation, let's do a darker color. If we set up an equation as 300 minus 2x, we need that price to be at least 0. We don't want any negative numbers. A negative number for price would mean that the people who will come to Earl's store are having Earl pay them to take a bike away, which doesn't make any sense and not a very good business model, if you ask me. So now if I solve this, that would end up as 300 is greater than or equal to 2x. And if I divide by 2, I would get 150 is greater than or equal to x. So we figured out that our price can only go as high as 150, which even if it's 150, that's kind of just a price of 0. But we would basically be x is less than 150, but we'll kind of keep that 150 as our main thing here. So let's get rid of our writing here and use 150 as our maximum for our domain. So our X number of bikes goes up to 150. So now at least we can start seeing some of our equations. So now we are going to need to zoom out and look at our range. So we know we're going to keep going upwards with range. Our range right now is, we want to start at, well, we can leave -5 because we could have negative profit or negative money at the end. But our Y max, well, so let's go up to maybe 100. Well, we can't quite see. We're looking for the top of our profit, or where our blue and purple are intersecting it. So we can kind of keep going a little bit upwards. And so if we keep moving upwards, so if we maybe go up by another 50, well, we still can't see anything, so maybe we should go up by a little bit more, go up by 100 now. So well, we can still kind of start seeing it. We can kind of see where our revenue is over here. So maybe we can kind of we basically just need to kind of keep moving upwards. Now we can see our cost right here, kind of hitting our revenue, our profit function. We're not that far away. We're still pretty far away from seeing where our blue and purple equations, we can't even see our purple equation at all. So you can see how this is 5,000 for cost. Well, we definitely need to go at least to 5,000. So let's go jump up to 5,000. Well, we can start to see the top of our profit equation. We still need the top of our revenue equation. So if we double our 5,000 now to 10,000, well, now we're starting to see some stuff going on, and we can see where they're going to be crossing each other. So when our revenue and cost are equal is break even. So we find the intersection point of our revenue and cost. Well, we can see that our X values are about 23 bikes and about 106 bikes to break even, where our revenue and cost are equal. So that's the first main thing we wanted to find out. The second main thing we wanted to find out is how can we maximize our profit, which is basically going to be the biggest difference for an X value, where our revenue and cost are the furthest apart from each other. And so if we maximize profit, our profit equation was in green. So if we click on our profit equation and find the maximum point, we see that the maximum profit we can make, the biggest difference between revenue and cost, would be $3,450. And that is if they're selling 65 bikes. So if you are Earl, you wouldn't be trying to sell as many bikes as possible, because then you still have to make those bikes, and then you start to lose more money. But you don't want to sell too few bikes, because then your revenue isn't big enough, and you haven't quite overcome your fixed and variable costs quite yet. And so the sweet spot here for making the most profit if you are Earl is 65 bikes, giving you, like I said, $3,450. And that is what you be shooting for. And if you have a firm understanding of polynomial functions and the data of your bike sales in the past to look from, you could create equations like the four we have created on the left-hand side of our graph in order to get this data and make a very informed decision on your business. And that is what Earl has done. And that concludes this polynomial modeling problem involving price, revenue, cost, and profit. Thank you for watching.